Hello, can you hear me?
Yes, Durga, can you hear me?
Yeah.
Yes, yes. Okay, just give me 1 minute. Just give me 1 minute. I'm checking something. Okay, so good evening, Durga, and welcome to the TestprepKart demo session. I am Rohit, and I am the faculty of Physics at TestprepKart. I have been associated with TestprepKart for last 5 years, and I have done my BTech in Mechanical Engineering from IIT Madras. When I appeared for JEE, my rank was 875, and I got Mechanical Engineering there.
Wow.
So now today we have this demo session of physics, and so you are in class 11th, right?
Yeah.
Okay, good. So what we'll do today we'll discuss, one of the topic. I think you have mentioned mechanics,
Right.
which you want to discuss, right? Okay, so I'll discuss with you um, the chapter on mechanics, and then we'll have some discussion of the question at the end.
Okay.
So just give me a minute. I'll upload the book here in the classroom. Okay, so what are the chapters that you've done in your school till now?
For now in grade 11, because we just started, we did uncertainties in measurements and vectors, and we've just started mechanics in grade 11.
Okay, so in mechanics, have you done equation of kinematics like V is equal to U plus AT, S equal to UT plus half AT square,
No, we haven't
V
started
square
any of that.
okay, got it. So see, whatever we'll discuss today, right? It will be on that, and I'll see that what. So you have done vectors in your school?
Yeah, we've done vectors, all types of vectors, vector resolution, etc.
Okay. So I'll see if I can if because in half an hour we'll see that what is the maximum thing that we can cover. Otherwise, we'll have a discussion on the chapter on vectors then. So this particular chapter we are starting with a discussion on displacement and distance. See, mechanics it has many subtopics in it. So we can divide that into two parts. One is kinematics and second is dynamics. Now, when we talk about kinematics, it deals with only one part of the motion. That is what is speed, what is velocity, what is acceleration, all those concepts. Now, then we have dynamics. See, here we have a free body diagrams. Here we'll discuss about uh, the forces. So in this, the first part of this, which is on what part of the motion we'll discuss about the velocity, we'll discuss about position of the body, we'll discuss about displacement.
Okay.
So let's say if a body is at rest in the beginning, So if you look at any body, any particular particle in the space, it can have two states. It can be either in motion or it can be at rest. Right? We say the body is in motion when or first when it is at rest. We say the body is at rest when its position changes with respect to time. Sorry, this is motion, sorry. This is rest. Rest is when its position does not change with time.
Okay.
Even the position of state, which is the rest or motion, it is relative. When I say relative, let's say if the train, if in this one person is here A and there is another person B who are sitting next to each other, there is a person C on the ground. If the train is moving like this, fine. If the train is moving like this on the ground, then what person A will say about B is that B is at rest.
Right.
Because they are sitting next to each other.
Right.
But what the person C will say, as per him, A is moving.
Right.
So what I meant to say is position of state of rest and motion both are relative to each other.
Okay.
So now any object, right? Let's say it is here in the beginning at A, right? This is the position of the body. Let's say the body goes like this in space and reaches to point B. So this is the final position of the body. Right? Whatever is this total length of the path covered, that is called distance.
Okay.
So it is right? It is a scalar quantity. Whereas next you have is a displacement. Where it is a vector joining the initial position it is a vector quantity. Right? So any vector which joins the initial position of the body to the final position is called a displacement. So this is a vector quantity, this is displacement here. So when the body moves from one position to another, right, it will have a displacement, it will have a distance, right? But how fast the body is moving, that we measure by using a new term or a new factor which is called speed. Right? So so speed is the rate of change of distance of the body. So here your speed can be written as total distance by total time. Speed is a scalar quantity, because distance is a scalar, time is a scalar, so its net is also going to be scalar. And can you tell me what is its unit?
Sorry?
What is the SI unit of speed?
Meters per
Looking at
second.
its formula. Correct. Meters per second. You're right. Now then we have velocity. It is the rate total displacement by time taken. Its SI unit, it is a vector quantity, and its SI unit is meter per second. So this is what we have in this. Now next is acceleration. See, when the speed is not constant, velocity is not constant. You might have observed that, okay, the velocity starts from 0, it goes to some 100 and then 40, then 0. So that rate of change of acceleration, velocity is called acceleration. Rate of change of so acceleration A is change in velocity by time. And its SI unit, what do you think is the SI unit of acceleration?
Meters per second squared.
Correct. And it is a vector quantity. So you have to take care of the direction.
Right.
This is acceleration. Now next is analytical equation.
Okay.
When the body starts, it starts from with some initial velocity. So u is the initial velocity here. V is the final velocity. Right? So there are three equations that we have. First equation is V is equal to U plus AT. Take care of the direction. If you are taking right direction as positive, then the left direction has to be negative. Right? Second, S is equal to, okay, S is
Displacement.
S is equal to ut plus half at square.
For the first equation, we're assuming that acceleration is constant, right?
In all these three equations, acceleration is constant.
Okay.
That is only assumption.
Okay.
These equations are not valid if acceleration is not constant. In that case, we have to use a different concept, which is the instantaneous concept,
Okay.
where you have to use integration and the differentiation concepts to solve this.
Okay.
So these are the three equations. Now, after this, we have the graphs.
By the way, what are the derivations of these equations? Because I've seen these equations before, but I'm not sure of how they came up to be, like especially the second and the third equation.
Okay.
Is it by rearrangement?
Okay, so the derivation wise.
Okay.
I'll show you the derivation. So average velocity is, if acceleration is constant, it is given by u plus v by 2, right?
Right. Yeah.
If acceleration is constant.
Yeah.
Now from equation 1, And also there is one more thing. Total displacement is V average multiplied by time.
Right.
So can I say S is equal to U plus V by 2 multiplied by time?
Yeah.
But from equation 1, which we have written there, V is equal to U plus A2.
Yeah.
So it's going to be S is equal to
Okay. Okay.
That's how you get the second equation. Now, third equation is also in the same line. You know S is equal to U plus V by 2 multiplied by time.
Right.
But you also know V is equal to U plus AT.
Right.
So can I say T is equal to V minus U by A?
Yes. Hmm. Okay.
Any doubt?
Got it.
Okay. So this is what you have in this. Now next is the graph. So let me use the book because from here it will be done easy. So need to show you all the graphs. Okay. So this is a displacement time graph. Now the displacement time graph, if you look at it, if you get a line like this, it means the particle is at rest because its position is not changing.
Okay.
When you get a straight line like this, it means this is a constant velocity.
Right.
And the slope of this line is related to the speed and or the velocity of the body. So if you see here, this is the straight line.
Yeah.
If you have to find the speed of the body, just find the slope of the line.
Okay.
Now the most important one is, so there are two types which will do, usually. One is a displacement time, where this is the time t is here and the position of the body is here. If you show the line like this, it means it is a rest. But if we show it like this, it means it is a constant velocity. However, if it is an accelerated motion, you get a graph like this, parabolic.
Hmm.
And acceleration is greater than 0. But if you get a graph like this, it means acceleration is negative.
Okay.
So in position time graph, looking at the graph, you can find what is the displacement of the body just by finding the distance. And second is the slope of tangent to the curve
Okay.
gives velocity. Now next is velocity time.
Right.
In velocity time graph, if you get a, let's say, graph which is like touching the x-axis,
It's at rest.
so here you have a v0, yes,
Right.
body is at rest. But if you get a graph which is like this, then it means the body is moving with a constant velocity.
Yeah.
and if you get a graph like this,
Acceleration.
acceleration is greater than 0. You get like this, it means acceleration is less than 0. Now, with the VT graph, you can get all the three things. The first is, by looking at the graph, you can say what is the velocity of the body. Second is, if you find the slope of line, then it gives you the acceleration. Third thing, if you find the area under the curve, then it will give the displacement of the body.
Right.
Any doubt?
No.
Okay. So now next is, so that's what we have in this. And let me so this we have done. And make sure whatever area is above the time axis, right? It means the displacement is positive.
Okay.
Whatever area is below the time axis means the displacement is negative.
Okay.
These anyway we have derived. Now, okay, we'll look at these questions. First, we'll look at the question which are there. So let me see what this we have done. This. Okay, now next is the motion under gravity.
And this all comes under kinematics.
Yes.
Okay.
There are three more topics.
Okay.
After this. So motion under gravity, let's say when you throw any object vertically, either up or down, the body goes up, right? And it will experience an acceleration in a downward side.
Right.
Which is always equal to g, which is 9.8 meter per second square in a downward direction. So, as a sign convention, all the upside will take it as positive and all the downside will be taken as negative.
Right.
All the upside is positive, all the downside is negative. And so if you are throwing some object upwards, so take V as positive. If you are throwing something downward, take V as negative.
Okay.
So here the equation will now reduce to V is equal to U minus GT. S is nothing but H, which is UT minus half GT square.
Sorry, where did you get the H from? Sorry?
H is the height. In place of S, you write H.
Oh, right. Okay.
Y minus 2gh because acceleration is negative.
Yeah, okay.
See, whenever you throw any object upward, right, it will keep on going up. In the time, its velocity here will become 0.
Right.
At the rate of h max. And after this, it changes the direction and then it falls. So, let's say, in such cases, right, they won't give you these words that, okay, the object is thrown upward and find the height, find the maximum height of the body. So, you should know, at maximum height, V will become 0.
Right.
This is one. Now in addition to this, so this is if you see, right, everywhere I'm just talking about the motion in one direction. The body is either going up or coming down, going like this or coming back, right? So next is projectile motion. In projectile motion, you throw any object in here like this, it will go up, then it will come down. Here it has this, two component. One is vertical component.
Yes.
The second is the horizontal component. So if you notice that here, if the angle of projectile is theta, then initial velocity can be written as ux is equal to u cos theta,
Yeah.
and uy is equal to u sin theta. Right?
Right.
And acceleration is ax is going to be minus g, right? And yes, so that's what we have. So in this case, what you do, you study both the motions separately, because x and y direction motion, they are independent of each other. So it is not ax, this is ay. Ax is 0. Ay, sorry, ay is minus g, ax is 0. Because
How
horizontally,
are you getting the like components of acceleration? Like, where are you getting it from?
acceleration is always in a downside, right?
Right.
G is always downward. So ay is minus g.
Right. Okay.
Along horizontal, there is no acceleration.
Okay.
Where initial velocity is u cos theta, u sin theta. Accelerations are going to be minus, here it is 0 and here it is minus g. V is going to be u cos theta every time. Here it is u sin theta minus gt. And s is going to be u cos theta multiplied by t. And here you u sin theta t minus half gt square. And so if you have to find the time after which the body will strike the ground again, that is called time of flight.
Right.
So this is the time after which the body strikes the ground again. So at that time, y will again become 0, because the particle is starting from here and again hitting the ground. So to find that, what do? You put u sin theta t minus half gt square as 0. You get t as 2u sin theta divided by g. Right? Any doubt?
Yeah, I didn't get how you got, like, why are we taking the y again? Because that's when you want to solve for the t?
Yes. So actually I want to find how much time, let's say if I'm throwing any ball in air, it goes up, then come down. So I want to find after how much time will it hit the ground.
Right.
Now how will you find? You take one component which you know, you take one displacement which you know. I know that in vertical direction there is no displacement, because first it is going up, then it is coming down. So the net displacement along vertical direction is 0.
Right. Yeah. Okay.
So that's how you get it. So this you do for time of flight. Then we have range. Range is the horizontal displacement of the body. So that is nothing but horizontal displacement. So R is equal to ux multiplied by t. Ux is u cos theta and time t is 2u sin theta divided by. Right? Any doubt?
Yeah, I was just trying to get how why you'd use the cosine one just to find the max. Like, why did you use that in specific? Is there a reason why?
No, that is the range, right? Range, let's say if I want to find how much is this displacement, so I'll consider only the displacement along x-axis, and for
Right.
that I have to take all the horizontal component. Now ux is nothing but horizontal component of velocity,
Okay. Yeah. Okay.
right? X,
Yeah.
for x displacement you will use this formula,
Okay.
and this is the time of flight that we have derived, and this is what you get.
Okay.
Now to find the maximum height, so you know that at h max Vy will become 0.
Right.
Yeah. Right? Any doubt?
So you substituted the Vy to be 0, and I understand how you got but the other side of the equation on the right hand side where you try to get acceleration, that is from, isn't it just negative g?
Negative g, yeah. Negative g is the acceleration.
So what is the, oh, it's the 2 times, oh, okay, yeah, okay. It's 2 times, I thought it was 2x, sorry.
Yes, it's 2 times.
Okay.
Okay, so this is what we have done. Now let me just give you one question, and meanwhile let me get one test paper also for you. And just try to solve this question. This question number 1.
Question number, oh, okay. I can't see.
Just try this. Meanwhile, I'll get that test paper.
Horizontally from the top tower. Study from near my initial horizontal. Like that. Does this have to do with the projectile thing? Because to fall like that.
Horizontally. Okay. Okay. So in this case, it is fired like this.
Right.
It's not a complete projectile. So what you have to do, initial, what is the horizontal component of velocity? What is the vertical component of velocity? Study the vertical component separately and the horizontal separately.
Right.
The only difference is here the initial velocity is not u cos theta, but it is u.
Sorry, what did you say? Sorry, I didn't get what you just said.
So here initial velocity is not u cos theta, but it is going to be u only. The vertical component of velocity initially is 0.
Right.
Because you are firing some object horizontally.
Okay. So then if it's 0, then how are we supposed to know what the angle is or to calculate the time taken?
No. See, you know that when it hits the ground, right? What is the vertical displacement?
The 0?
Draw the table. Okay, 1 minute. First you draw the table in your notebook. Write the initial velocity,
Right.
both x and y component.
Initial velocity. So the x component of the initial velocity would be 30. It would be 30. And the y
Yes.
would be 0.
Correct. Good. Now you have to draw on. You have to just read some words. It says 35 meter. What is 35 meter?
The max height.
You are throwing something from height. Ultimately, where the object should fall?
Like 0.
On the ground, right? So what is the vertical displacement?
Sorry, what is the vertical displacement?
Yes.
35.
When you're throwing some object, minus 35, not 35, minus
Right.
35.
Okay.
Because the object will go down ultimately. You know initial velocity. You know the vertical displacement. Can you find the time taken to reach to the ground?
Oh, it would just be the displacement is negative 35, and that over the because that's your vertical displacement. So how would we find the horizontal displacement?
That you don't need to find first. For finding the time, you don't need horizontal displacement here.
Okay.
That you'll find by using the time t. You can find that later.
Right. So wouldn't you just put it
First
in?
to find the time.
Wouldn't it just be
Yes.
negative 35 over? Sorry, negative 35 over 30.
How will you do that? See, I told you vertical and horizontal motion has to be studied separately.
Okay.
Ux is 30,
Right.
but Uy is 0.
Okay.
Sy you know is minus 35.
Yeah.
Acceleration along y direction you know is minus g.
So
Fine?
you would use all the vertical components and not any of the horizontal ones.
Yes. Because they are independent of each other. Only thing which is common between both is time. Otherwise they are independent.
Okay. So you'd put it into the one. So, like, I'm not really good with remembering the different equations, but one of them was what is the time, like distance is equal to v squared, u squared. That was one of them, and then there was a second one, which was.
Have you made a note of those equations?
No, I need to take it down. I haven't taken it down.
Okay. Okay, so
I think I'll write it down.
let me just see. I have given you the three equations. V is equal to u plus at. S is equal to ut plus half at square, and v square minus u square equal to 2as. Now you have to find the time t. Now to find the time t, what you do?
You can use the second one because that has all three except for time.
Yes, can you solve it?
So if I were to rearrange that equation, I get s is equal to t times u plus half at. So s is equal to negative 35. And negative 35 is equal to ut t times u was 0 plus plus u minus 4.9 t, and then if I were to, so it's t times, so negative 35 is equal to 0 minus 4.9 t, so negative 4.9 t squared. Okay, where's my calculator? Negative 35 divided by 4.9, 7.14, and if I were to square the answer, I got 2.67 seconds.
Okay. What is the answer you say?
2.67.
Okay, let me see. Correct. Can you do part B? For part B, what you do, whatever time you got now, right, just multiply it with the horizontal component of velocity.
Because time is common for both of them.
Yes.
Okay, so 2.67 times 30. 80.18.
Correct. Can you do part C?
The velocity at which the arrow strikes the ground. So when it touches the ground, is it like the x of the velocity, like the x component of the velocity is equal to 0?
You have to find the velocity when it hits the ground. So horizontal component will not change.
Right.
Right? But vertical component will be there. You have to find that. You can say that x component will remain the same, but vertical component will change.
Okay. So vertical component change. I mean, we have the vertical component of the distance, the displacement, right? And we have the time. So could we just divide the two to find the velocity?
Yes.
So
you know v is equal to u plus at.
right? And since your acceleration is the same, we could say, so the initial velocity is 30 plus 9.8 times, negative 9.8 times the time taken, which is 2.62 or 2.67. So it's 30, wait now, 9.8 times, what was that? Time was 2.67. It was 30, 30 plus 9.8 times the time, 30. I think it's like 3.8 meters per second.
Okay. So for vertical component, you have 3 point, how did you get 3 point something? You have to just do v equal to u plus at, you got the value of t as 2.6.
Right?
Right? So you have v is equal to u plus at.
Yeah.
So vy component is going to be 26 meter per second square, meter per second. Negative side going down. Take gs 10.
G is 10, right?
The
Yeah.
value of G is 10.
Okay.
Yes. So U is 0, Uy is 0,
Oh,
plus
yeah.
A is your 2.6.
Okay, yeah, I got.
See, vertical and horizontal component has to be studied separately.
Right, I keep confusing that.
And
Okay.
Vx will remain same as Ux.
Right, okay.
You can say the final velocity has two components, one is 26, other is 30.
Okay.
See, there is one paper which, just give me 1 minute. Okay, it's already uploaded. 1 minute. So let me check this now. Okay, sorry, this is actually the entire mechanics, right? Whatever we have. Let me see if we have some question on kinematics. Otherwise we'll solve some question on vectors then. Can you try this? Here look at the angle. Angle is with the vertical, not with the horizontal.
So the vertical would be cosine and the horizontal will be sine, right?
Yes.
Okay. Gee, what is the time taken for the stone to hit the surface of the lake? So we have time. Wouldn't it just be 2v sine theta over g to get the thing?
Why?
Because one of the
See,
equations.
that time, see, that equation was 2u sine theta divided by g, right? Which we had derived for time of light.
Right.
And that theta was with the horizontal. Now it is with the vertical.
So it would be 2u cosine theta? Right.
Yes.
Okay.
So there are very limited questions here on this. Let me see. Can you look at 16?
Wouldn't it be 0 at the start? What do they mean by like when it's dropped? So, I mean, it should be constant, right? Acceleration should be constant throughout the motion, but at the start, isn't it 0?
Yes, it is 0. Now 17.
Which quantity is 0 when the ball is at the highest point? Horizontal component of the ball. It's the kinetic energy of the ball.
No, at the highest point, just think, the horizontal component is nowhere changing.
Right.
Only the vertical component becomes 0. So even if you have horizontal component, you cannot say that the kinetic energy is 0.
But
Its vertical component of the velocity becomes 0.
that's this vertical component of the ball's acceleration.
It is A. Answer is A. There is no acceleration in a horizontal direction.
Right. That's the same for
Right?
X, Y, and Z. Right.
Hello?
Hello?
Yeah. So even AY is 0.
Right.
Yes, yes. 1 minute. See, in this, let me see few more questions. Check if this graph
Sorry?
is not clear, you can leave it. Just to get the next one. Look at 19.
Again, initial displacement. Alright. Then it comes down. The velocity. Right. Velocity stops. And then goes back. Goes up. I think it's B. I'm trying to understand because are we saying that the water is moving like this? Or something? Like that?
When allowed to oscillate, the motion of the liquid is recorded using a motion sensor. Okay, see, one thing is, anyway, this you might not have done. Whenever some oscillation happen, right, some SHM happen, it is always represented in the form of a
Okay.
sine or cosine curve.
Right. Okay.
So this is your sine or cosine curve.
So it is applicable to any oscillation.
Any SHM, any oscillation when you say it is not dampening. So basically the external force we assume that its external forces are 0. Okay, so it has very limited questions. So let me give you one set of paper which has vectors in it. Let me just upload this one. Can you look at 12?
Particle P moves from A to B. Particle Q moves from C to D. Displacements for P and Q are x, y, respectively. Then displacement is 2 and Q square. The total displacement would be 4 plus 1 square root of 5.38, and then for this one will be 3, 4, 5. So this one's greater. C to D, 3, 4. It will be the magnitude of this. So AB is greater. Is it A?
A. Okay. A particle okay. A to B and particle Q. P move from A to B. And Q move from C to D. So this is 5 and this is root of 26. You said A. Correct.
Shape
Look
of
at
the
30.
graph of position. Time given in the figure for below shows the position over time. C. The body returns back to the origin. Yeah.
You're saying C. See, initial position is not 0. It is somewhere. So it is not moving with a constant acceleration because for that it has to have a parabolic. The body moves with 0 velocity. No, it's not moving with a 0 velocity. The body returns back towards the origin. Okay, it is mentioned towards the origin, right? Then it is okay. Okay, so if you see, right, we have solved total 6 problems. One we have solved the that subjective one. So I'm just leaving that. So in total, if you see, we have solved 5 problems, and out of that, you have answered 3 correctly, and 2 were wrong. So as you can see on the right here, moderator has mentioned that he has already shared the course details for IBHL, and regarding this, he will give a call to your parents maybe tomorrow.
Sorry, but I think I lost your video.
Okay,
I didn't hear what you
so
said.
with this, Durga, now the session is coming to an end, and then see you, yeah. Yeah, so what I was saying that, as you can see on the right, moderator has mentioned that we have already shared the course details with you.
Okay.
And regarding this, he will give a call to your parents. Okay, so thanks for joining this, and now you can log out from the session. Bye, thank you.